Hi guys, welcome to my YouTube channel. I hope you are fine. Me too, I'm fine. So guys, today we are going to look at partial differentiation. So guys, we read this question. It says, given that z is equals to natural log of tan x plus tan y, prove that sine 2x partial differentiation of z with respect to x plus sine 2y partial differentiation of z with respect to y is equals to 2. So guys, when we come now to differentiate this one using what we call partial differentiation, we consider what we are not differentiating as a constant. So if we are saying partial differentiation of z with respect to x, we take tan y to be a constant. So if we come now to differentiate, that is partial differentiation of z with respect to y, we take tan x as a constant. So this variable x is now no longer variable, it's considered as a constant at that moment. So guys, let's start and see. The first thing guys we are going to do is the partial differentiation of z with respect to x, like that. So now guys, we do like this one, taking tan x as constant. So the first thing we do is we differentiate from the outside, ln that. We take it like the way we say ln x, and when we do that we get 1 over x. But now our x is now supposed to be tan x plus tan y. So after doing that guys, we again differentiate from we start from the outside. This is actually the chain rule, but I am not, it's like I'm using a shortcut for the chain rule. So I come now and differentiate the inside while taking now y as a constant. And so when I differentiate that, I will now have tan x becoming sec squared x, because now this is a constant. When you differentiate a constant, you get 0. Then coming now to differentiate with respect to y, that is partial differentiation of z with respect to y. This one now gives us, first of all, you differentiate like we have said, that is z equals to ln, and that whatever is inside there, you get 1 over, whatever is inside there is tan x plus tan y. Please note guys, I'm using the chain rule, only that I'm doing it off head, but for you, you can try and do with the chain rule and see what you get. Then I take that tan x is a constant, so I'm only differentiating tan y, and the tan y gives us sec squared y, like that. So now guys, I've already done partial differentiation. It's now just to come and prove our equation here. And so guys, I will write sine 2x sine 2x, and this sine 2x can also be written as sine x cos x and then 2. This is according to the trigonometric identities. Then I multiply that with dz that is partial differentiation of z with respect to x, which is this first one. So this one is now going to be, you multiply that with sec squared x all over tan x plus tan y, like that. So we can take that and deal with it first, and then we shall come to this other one. We start with this, and this is supposed to be equal to that. So let's finish with it and see what we get. This one now will be equal to, we don't have to write equals to, we just write 2 sin x cos x. This sec squared x is reciprocal of cos. So we can write here all over cos x cos x. This is actually 1 over cos squared x. And then we have here tan x plus tan y. So once we do that, guys, we can cancel that and that. Then we are left with, here we are left with 2 sine and cos. We give it, get tan x, like that, all over tan x plus tan y. So that is what we are left with after we have cancelled that, because sin x cos x is tan, and then we are left with that one. Guys, this is our first, this is now equal to, supposed to be equal to sine 2x partial differentiation of dx with respect to x. So let's go to the second one, guys. We are looking for now, what we are looking for is sin 2y partial differentiation of z with respect to y. That's what we are looking for, guys, from this, from our equation here. This is what now we are looking for. We have found this one, and now we look for this one. We add them, we see whether we get 2. So guys, I go ahead and now find that. So that one will now be sine 2y, you multiply by now this value, which is sec squared y all over tan x plus tan y. So that one gives us that. So we still do the same with this one, because we are going to have sine y cos y and then 2. This is according to the trigonometric ratio or trigonometric identity of that. Then sec, we can put it here, which is now cos y. Then we are left here with tan x plus tan y, like that. So guys, this is now going to cancel. Cos will cancel that, and then we are left with 2. This sine and cos is tan y all over tan x plus tan y. So guys, we've been able to find our sine 2y partial derivative of that. So guys, we can now come and add this. We add that value to this other value, and let's see what we shall get. So we shall have sine 2x partial derivative of z with respect to x plus this other one, sine 2y partial derivative of z with respect to y. So this one gives us now, for the first case we had 2 tan x all over tan x plus tan y plus, and the second case we have 2 tan y all over tan x plus tan y. So let's see what we shall get with that. So guys, we can, because they are the same under the same denominator, we put them under the same denominator. This will be tan x plus tan y. I have combined them because the denominators are the same. Then I come and put 2 tan x plus 2 tan y. Guys, from there I can now factor out the 2. So 2, and then we are left with tan x plus tan y all over tan x plus tan y. So guys, as you can see, the tan x plus tan y can cancel. So we cancel that one and we cancel that one. And so our solution is supposed now to be 2. So guys, that is our solution. And we have now been able to prove, as you can see from our question here. The question reads, prove that this is equals to 2. Guys, we have done it. And so, thank you for listening to me. Bye bye.